Hey guys, how's everything going? This is JSer, who is not good at algorithms. In this video, we're not going to talk about algorithm. It's about JavaScript basics. Specifically, I'm going to implement a low-dash sorted index and by myself, and there are several other related functions. So maybe we can do it together. So let's start. The first one is low-dash sorted index function. Actually, I've never used it before. This function uses a binary search to determine the lowest index at which the value should be inserted array in order to maintain its sorted order. So like 3050, we insert 40, so it must be 1. So insert at this position, right? Okay. So let's try to implement it. The function would be a sorted index. We got an array and a target. And we need to find its appropriate index, right? If it is init, let's first define some of the test cases, right? If we sorted index like 1, 2, 4, 5, if we're gonna insert one sorted index of 1, it should be 0, right, at the beginning. And yeah, and the next one, it should be like 2, it should be 1, right? Okay, for 3 is not in the array, but it should be here, right? So 2, and the next one, 4 isn't it? So it should be 2. Now if we get 5, this is last one, so 3. And 6, if we get 6, maybe 1, 2, 3, 4, 5, right? 0, 1, 2, 3, 4. Okay, so this is a test case for sorted index. Let's try to implement it. So the idea is simple. If we use binary search because it's sorted, we use binary search, and we choose the middle. We choose a middle. Wait. Like A, B, C. If target is smaller than B, this is the middle one. If the target is smaller than it, then we set to A, right? Because target is before B, and if it is bigger than it, B, we go to C, right? So okay, okay, there's more elements like here. This middle. Okay. If target is bigger than middle, then it should be middle plus 1, right? Dot, dot, dot. If it's smaller, then we might middle minus 1. So there will be a for binary search, there will always be considering the ending condition, right? So if we got the last element like this, like a number, and we compare it to target, if we found it, of course we can just return it right away, right? Just the middle plus 1, the next one is the next number. If itself is the right index, we just return middle. But for num, if we only one number, we get target. What we have, the ij actually the start equals to mid and end equals to middle, right? And then become compare the target. So this is the number. If target is bigger than it, but we already start set to end, right? So next one must be bigger than target. We already checked, right? So the next one here is bigger than target, and this one is smaller than target. Then target must be between this, right? So we set star plus to 1. and it surpass end, so the check ends. So start actually is will be like will be something like end and the target and start, right? Let's suppose that is a 2 number, like A, B, and of course start equals middle, but equals end minus 1, right? Now here, it means the middle is smaller than B, but bigger than A. Now we choose the middle. Oh, no, it's smaller than B, bigger than A. Now we can still choose the middle, compare, because it's small, smaller than target. The start will +1, right? So it will be it will be B and B, right? So it can become the previous one. So now what do we become? And then it will become end minus 1 because the middle is bigger than target. And I still, you see, still it becomes end target start. So no matter how, we just move the start further or move the end to a little more to the head. It will always end at this end target and start. So we return start, right? So this is our idea. Okay, let we just use start 0, let end equals arr.length. Okay, minus 1. While there's some problem. If we do while loop here, it might needs to infinite loop start equals to end. We can still compare if they are the same. Okay. Infinite loop. Okay, I'm sorry. I'll just first comment it out. So we choose the middle equals math floor, which is the left side. Okay, now we compare the target with the middle number. If target is middle, ARR middle, if it is the middle one, then because okay, the assumption of array is it's being unique, so there will be no duplicates. If you find this, we could just return what? Return the middle. It's the index we want to be. Else, if target is smaller than AR middle, then it falls on the left side, right? So end equals middle minus 1. Else it's bigger, right? Start equals middle plus 1. So every time we will move end a little further, or start a little end a little backward, or start a little bit further. So like the case of 2, 5, the start will actually, if we search 3, the start actually falls to 4 first, and then we choose 2 because it's bigger, so we go to 4, 4. 4, 4 is smaller, so we move the end backward, right? So where is the index? Of course, it's start actually. We turn start. Let's see if it works. Cool, it works. So we've done the binary search actually. This is a binary search. But if it is in it, this case means it says we maintain the order and return the position, right? Let's try if this works. Okay, it should be 1, I think. Yeah, cool. So our solution is good. Now let's continue. continue one thing. Okay, not here. Sorted index of. Okay, this sorted index by sorted in index, and this is by. This except the iterator invokes value each man to the ranking. It's okay. Now sorted index of. It says if it is it, or return -1. Well, so so actually there is a problem. We're not sure whether it exists or not, right? So we just return the index, but if we want to return something like this, if it exists, we return the index. If not, we return -1. So how we do that? Let's try to refine our case here. So here it should be a -1, right? And this one should be -1, and this should be okay. Okay, let's revise it. So this will end actually when at start. So the number actually if we match the start, we return, right? But it's not, so we return -1. Oh, the third one, it says false. Well, this is -1. Cool. Yeah, you see, we just return -1 here, and we got a sorted index of. So now if we take a look at the sorted index, if we take out the example here, we have noticed that the input of array might contain duplicates. So this is our case we need to handle. For case, if like we want to search like this, first, we need to search the first index, like for this, 5. Allow me to comment this out. So log sorted index this equals 4. Of course, it's not the first one, right? So it returns 1. Well, because there's a duplicate, we cannot return immediately, right? Like here. So how we do it? Well, let's say if like when we get the 1, 2, 2, 2, 3, we search for 3. We first should compare middle, right? If this one is 2, search for 2. If this one is 2, because it's sorted, we need to check previous again, the previous half, because it might has to or doesn't have to, right? It might have to or not, but the latter half could be ignored. We could just move end to middle and continue doing the check, right? What if the last, when we, okay, the next time we will compare 2 again, and then still we move end to middle, and then we will compare 1 again, and then move I, and then we compare it, and it's the same. So we move middle. Okay, we move to backward, and then I stop at the index. So we just suppose that these two are not exactly the two, but slightly different. We can just continue doing the search like we did in sorted index. Am I right about this? Maybe. So the idea is we move to the previous two. The first one is because it's a smaller target, it's smaller or equal to it, we set it to middle 2. So the next one is 1, 2. And now we need to check the middle equals 1. It's bigger than it, so we need to check 2, these 2, right? The 2 here. And then we compare it because it's there. So we will move to actually empty, and then I will stop at this one. So start, we return start. It's actually the 2. What if this is 1? It's the same, right? We go to 1, and then because it's bigger, so we go to this one. Because it's bigger, I will move to these two. Start. Right? Okay, so actually there is no return immediately. Is a check here. If target is smaller than it, we move to this one, or else we move start next. So start actually will be pointing the possible two, if this is the first two. But it might be first two or not. So we say return, okay, return start, wait a minute, array start if equals to target. If it is target, then we turn the index, which means start. If not, we minus 1, right? So yeah, if we search 5, it's 1. Okay, now we search 3, it should be -1. Yeah, cool. And the 6, 0, 1, 2, 3, 4. It should be 4. Cool. So remember, we always use a while loop with a condition smaller or equal to, and we compare the ending start index, right? If we're going to return if it exists, we compare the result, because if there is this target, it must be at the index of start, as we analyzed before. If you return the index, we return start. If we want to check if it exists, we compare the target. Okay, so we have done this one. Now, what about last index? Well, for last index, for 5, it should be 0, 1, 2, 3. So it should be 3, right? And still -1. And for if there's a 6th here, 0, 1, 2, 3, 4, 5. Okay, it should be 5. So let's revise it. We have the same idea. If it's bigger one, if it's bigger than it, then wait a minute. So we're gonna check the last one. If they choose these two, actually we should move start a little further, right? It might be like, okay, I'll do this like this. So we'll go to actually these 2, 3, and then compare 2, still 2. So we will go to 3, right? And 3, because 2 is smaller than it, so actually we'll go to end here. So I is the, okay, it's n is the last 2 here, right? Cool. Now what if it is 1, or if it's 3? So we got 3, 3, we got 3. So j actually will be here, end, right? So what do we do? If we target is bigger than it, or equal to it, we move start a little further. If it's small, we move the end, right? And at the end, we move end, or actually it's the same as start -1. We could try that. Okay, first here, I'll return, because we get the index, we get n. If the n is target, return the n. If not, we return -1. So yeah, you see, we get it. And we could still also use start -1. Start -1. Cool. So this is the same. At last, there will be checking one index. If that, it will be start will be bigger, one step further than the end. If it is 2-digit, it will be reducted to a 1 problem. So finally, it's a 1 element problem. So this gives us the last index approach, right? Cool. So now, if we don't return the -1, let's see how it is changed the okay, here. If we could just return n, right? So now here 5 would be, if we inserted this 5 to the last 5, it would be 0, 1, 2, for 0, 0, 1, 2, 3, right? So it should be 3 because it exists. Okay. Okay, and this one, index 3 minus 1 is true. If we return end, 3. Okay, 0. It's minus 1. It's just, yeah, it is minus 1 actually. If we got 4, it should be 0. It's cool. If it is a 7 and we get 6, it should be 0, 1, 2, 3, 4. Wait a minute. There's a problem. N. So this one should be the previous one. So, wait a minute. It should be, yeah, insert. It should be start. And here 5, 0, 1, 2, 3, 4. It should be 4. Here's a tricky because actually this 5 should be here. So this is the index of 6. This is a tricky part. For 6, it must be before 7. So this position 0, 1, 2, 3, 4. 6, 0, 1, 2, 3, 4, 5, 6. So it should be 6. Okay, so this is the sort last index and sorted last index by. It's okay. Now sorted last index of 0, 1, 2, 3. It's the same. Okay, so that's all for Lodash sorted functions. Now let's try to analyze this problem a little further. What if we are going to search the next element bigger than 5? Next element bigger than 5. What is it? Let's try to return that. So this should be 6, and first element bigger than it. First element bigger than 5. First element bigger than 7. It should be 7. And this first element bigger than 6, well, it's minus 1, right? We return minus 1. So let's try to revise our implement here. So what we're going to do is actually the same as this last index of. If the element doesn't exist, it actually equals. If the element does not exist, then it should be at the position we return, right? Start. It shouldn't it couldn't be the target. So what we do, as we said, we get the position of this target. Actually, this start is actually the next element. So we return array start. Remember, we insert the last element, which should actually be replaced. You can think of replace the last element, which is not 5. Okay, we return start. Okay, the start might be out of range. So if it is bigger than or equal to ar.length, then -1, not start. So true, yeah. So we get a function that return the first element, which one is bigger than it. So what if we're going to find the first element that is wait a minute, the last element, the element that is just right before 5, like 2, 3, 5. We do 5, we need to return 4. Okay, for this 5, I need to return just a smaller than 5. I need to return -1. And for this 6, I need to return a 5. So how can we do it? Well, as we did before, if you wanted to search the element right before 5, actually we just insert a 5, right? insert the 5, that will be the first 5 position, or where it should be. This is not a good solution position. It's like, suppose there is 3 and we search 4, so it should be 3, right? So the position, actually the element before that position would be just the element which is smaller than it, right? So if it's smaller than it, if the target is smaller than it, we set end, move end a little further, and start here. Right? So actually, insert the position in the start. So the start -1, which is the end, actually is our position to check. So if the end is bigger than 0 or smaller than the 0, means -1, and we return end. You see? We get it. And or we can use start -1, which is the same. Yeah, so the problem, if there is a duplicate, if you want to find the element just smaller than some element, or some element just bigger than some element, it's just the same problem as we insert that element and find the first index or the last index. I'll repeat this one more time. If you want to search the element just before 5, we just search 5, insert 5 in it, and that will be the position here. So the previous element will be what we want, the end, right? If we find the first element which is bigger than 5, then we insert this 5 in it, and that index will be our target. So that will be start. Well, it may be overflow, so we need to check it. Okay, you see, whether the array is duplicate or not actually changes our implementation a little bit, but the basic idea is the same. Remember, use a while loop with equal in it, and check the next index of start. When you move, if it's unique, if we found the matching of middle and a target, we return it right away. If not, we reduce half of them and do the check. So that's all for these 4 kind of variations. Okay, now if we're doing, since we have completed this one, let's try to do again about this problem, search insert position. Well, remember that, right? Let's just copy the code. If we want to, we are assuming that no duplicates. Well, that's simpler. Okay, well, let's do it. So what is it? Let's start equals 0. Let's end equals nums.length1, while start smaller than or equal to end. Choose the middle. Equals to target. Return the middle. Else if nums middle is smaller than target, we set start equals middle +1. In the other case, end equals middle -1. And if no one is found, return we need to return the index, right? Oh, return index is found, and if not, it will fall with the target. It will actually, as we said before, it will be something like end target a start, right? If you're gonna insert, yeah, what we return, start. Let's run the code. Cool. Submit. Yeah, we're accepted. So this is a binary search problem. And there's another one. It's first bad version. We got number 1 to n. Version 4 is the first bad. We need to know which version is the first bad version. So the problem is, like, there's something like this. It's kind of sorted. So again, this, we need to find the first x, right? So that's kind of like we are doing search like 0, 0, 0, 0, 1, 1, 1, 1, 1. And we need to find the first index of 1, right? We find the first index of 1. Okay, so we need to just do the binary search, and if we met 1, we move the end backward, right? If not, we will start, move next one. So it will end. If we try to insert 1 there, it will actually be what? N1 start, right? So the first one should be the start. You see, it will actually insert 1 here. So N1 start. So one position for its position actually be the start. So let's do it. Start from 1 to n. Okay, let's start equals 1, n equals to n. While start small or equal to n. The middle equals math floor. Start plus n divided by 2. If target is smaller than or equal to, there's no compare, right? There's is bad version. So if it is bad version, which means it is 1, middle, we set n to middle minus 1, right? If it is not, which means it is 0, then we move start a little further. Start equals middle plus 1. So finally, it will end here. So what do we return? We return the first bad version, right? Return start. Try to run the code. Cool. And submit. Yeah, accepted. So that's all for this video. What I want to say, why it's so slow? I don't know. Oh, there's a here. Guess number higher. Pick a number 1. You'd guess which number I picked. Okay. Every time you guess wrong, I'll tell you whether the number is higher or lower. Wow, I haven't tried this before. We can call predefined guess int. We can guess, which returns 3 possible result. -1, 1, 0. Wow, this is a typical form of binary search, right? We are guaranteed there must be as a number. Guaranteed there will be a solution, right? So, of course, let's start from 1, n equals n, while start smaller or equal to n, comes the middle equals math floor, start plus n divided by 2. And we compare if, let's say there's a predefined guess. If guess middle, okay, const guess check equals, we guess it. If check is 0, we return check, return middle. Else if check smaller than 0, my number is lower. So the target is on the right half, right? So start plus equals middle plus 1. For the else, end equals middle minus 1. Okay, finally, there should be a, you pick a number, so it should be valid. So I can return anything, but this actually will be not reached. It will be here actually. So we run the code. Wait a minute. I have some typo. Start end. Math forward. Start plus end. Check. We guess the middle one. My number is lower. I pick a number. Wait a minute. I pick a number. So if it's -1, it means mine is bigger. It should be slower. It should be lower. So I mistake this. We need to make sure that we understand you and me in the right way. This should be right. Cool. So okay, that's all for this problem. Oh, there is a guess number higher or 2. We pick a number. Okay, guess wrong. The guess number is higher or lower. However, when you guess a particular number and your guess is wrong, you pay. Okay, so this is not binary search. The basic binary search problem. So I'll leave it here. That's all for this video.